All right. So welcome to the weekly AiTech Agora meetings, everyone. And my name is Arkady Zgonikov. I'm going to host today's session. And our guest speaker for today will be Stefan Buijsman. Stefan is a new postdoc joining AiTech at the faculty TPM, TU Delft. And Stefan has a very interesting inter and multidisciplinary background, which involves computer science, philosophy, mathematics, AI, cognitive science, a lot of interesting work. And then, aside from research, Stefan is also engaged in popular science, science communication, writing. He has written several books on philosophy, on mathematics, and also recently on AI and its links to philosophy. And today, Stefan is going to talk to us about explainable artificial intelligence. So I give the floor to you, Stefan. If we have any questions, I think there will be plenty of time for that, right? And yeah, some questions. Meanwhile, just put them in the chat. I will manage that. Okay, the floor is yours, Stefan.
Yeah, thanks, Arkady. So yes, I'm talking about explanation in AI today. So as I think all of you know, and I don't really need to go into any depth here, is that we have all these new AI tools which are hard to interpret, and we want to explain why they give us the output they do. So specifically why for some input X, you get output Y, which could be the decision that someone is a potential fraudster, or the decision that there's a cat on an image, whatever you like. And the sort of philosophical work I'm presenting in the next 30 minutes roughly is on the question what the explanation here really means. So what kind of information qualifies as explaining why the output is what it is, and also some preliminary work on what makes for a good explanation, because here too you'll see that the definition I'm proposing will allow for some really uninformative explanations, which obviously we want to avoid somehow. So that's the philosophical plan for today. And I want to start with a bit on the kind of XAI definitions that you'll find in the technical literature, to show that there's not only some disagreement here, but also that these definitions tend to be very broad and can use some further refinement. So for example, you can have someone defining explainability as the ability to understand the logic of the AI, or an explanation as an interface between people and the algorithm that both accurately tracks how the decisions are made by the AI and is comprehensible. And I think we can all agree that this is what we want, but these kinds of definitions, including here the last one, which says that it's an explanation is some kind of meta information generated to describe feature importance. Most of them don't give you a very clear idea of what kind of information to provide to people in order to explain an AI system, or they can be like this last one, very specific on feature importance being the relevant case, where I think we should be a little broader in how we understand things. So this is more or less what the kind of explanations in the literature look like. And instead of going there, I want to take something from the philosophy of science, where there has been kind of a big debate on explanation going on the last 20 years, where a very popular idea is that explanations in science, generally speaking, are causal explanations. A bit of a disclaimer here that this is definitely not the only position. There are plenty of philosophers who disagree with this, and I think there's a debate to be had there. But for now, I will just assume that we can take on this idea of explanations being causal explanations, which you can see, for example, with very concrete attempts to explain something. So an oft-used example is that you can't really explain why a flagpole has a certain length by appealing to the length of its shadow. This sounds somewhat fishy compared to explaining the length of the shadow based on how long the flagpole is that's making the shadow. So that there's some kind of asymmetry here in what we think is a good counts as an explanation and what is just a derivation of one length from another length. And the idea being that this asymmetry of explanations tracks very well with the asymmetry of causes. That idea hasn't gone unnoticed in the XAI literature, so I'm certainly not the first one to appeal to this idea of explanations being specifications of causal relations. For example, an influential 2019 literature survey defines interpretability and explainability as the degree to which a user can understand the causes of a decision. But there's a lot more to be said here than just the idea that the explanations are causal. And to do that, I want to make a brief sidestep on causation. So the final account I will be presenting on explanation is by Woodward from the early 2000s. And he starts off also with this idea of causation being based on counterfactual relations. So you can say that a set of variables x is the cause of effect y if changing x's value produces a correlated change in the value of y. So if you look in counterfactual situations where x would have been different, then you see that similarly y would have been different. So changing the cause also changes the effect, and if there's no causal relation, then the effect will be unchanged. There's a whole bunch of further specifications on how exactly changes in X have to be made. So that's a bit where this image comes in. I think that's something which we can go further into in the discussion if someone wants to, but just to indicate that it's not simply if you change X in any old way, then Y has to change, but that the kinds of changes on the causal variables have to be fairly specific here. Okay, that being said, this idea of causation having some kind of counterfactual relation is then used to further explicate what causal explanations might be, where an explanation is typically seen here as consisting of two main parts. On the one hand, there's a kind of general rule, a generalization, if you will, that it relates these changes in the cause variable, so in variables x, to changes in the effect in variable y. So that there's some kind of description of how cause and effect correlate with each other. And then furthermore, you want to have the case that this generalization is such that it explains the current case, so that the variables x actually take value x, and that then means that variable y actually takes the output value that's been observed and that you want to explain. And then finally, the idea that this is a decent explanation if it's a good correlation, so if it's approximately true, if, as I was just saying, the current value is covered by this explanation, and if there is some counterfactual situation where the input variables are different, and your general rule, this generalization, also explains how the output would be different. So if we put this into the context of AI, the idea is that you will have an explanation consisting of a rule relating input values to output values, the rule has to be covering the actually observed output that you want to explain, so that it predicts that for the current input you would get the current output, and it will cover some counterfactual situations where you have different input and you would get a different output, also covered by this rule. That's the kind of minimal setup that this Woodward account from the philosophy of science requires for explanation. And it fairly readily applies to this XAI context. And what's interesting, I think, is that you will actually find bits and pieces of this idea spread throughout the literature, only taken separately. So we have these two conditions, a rule covering the actual case and a counterfactual. And we have a lot of these tools that have just one of these two aspects. So what you will see is that there's quite a lot of tools nowadays in the XAI literature focusing on just counterfactuals. This paper from 2018 made the idea quite popular that you can explain the output that was returned by an AI system by pointing to a counterfactual instance where you say if the input had been different, then this different output would have been returned. Now, that's half of what Woodward is proposing with his definition of explanation. And I want to suggest that this counterfactual approach with only providing a single instance only works really well if you find a counterfactual that suggests a plausible rule. So the second part of what I will be pushing as a definition for explanation. And there are different ways of going about why this might be the case. So here are two examples from sort of normal physics where you can see the difference. So if you have a first explanation of why a window breaks when a baseball hits it, then you might say, well, if the baseball had hit it at a lower speed, the window would not have broken. And I think this is something we fairly readily interpret because we link the energy with which the baseball hits the window with its speed. And we have all this experience with speed being a very important variable here. But if, on the other hand, the counterfactual you're presenting is, well, if the Earth had been much heavier, then the window would not have broken. It takes a while to comprehend how this counterfactual, which is true, if the Earth is heavy enough, the baseball would hit the ground before reaching the window, and then the window wouldn't break. How this might explain the situation in any way. Now, obviously, these two examples are very convoluted and not really in the AI context. Though I would suggest here that the second is not a good explanation because it doesn't have a very plausible covering rule, the response could very quickly be that, well, these kinds of counterfactuals are very distant from the actual case under consideration. You see a lot of mention of counterfactuals in the XAI literature having to come from a plausible subspace of possible inputs where you might say that the Earth being much, much heavier isn't very plausible in this case. So this could be one response to why just counterfactuals are enough. I think the issue here is that there are still quite a lot of close counterfactuals which fit all of these conditions and still don't give us a clear reason why the output was returned the way it was. So to give some examples of from the sort of range of natural adversarial cases, the sun here on the left might be interpreted correctly by the AI, but if you show it a picture of the sun in ultraviolet light, it might very well, like in this particular instance, classify it as a jellyfish, where showing this counterfactual won't tell you anything about why the AI was correct in the case of the image on the left, or vice versa, why it was wrong in the case of the image on the right. And this can happen even with very small changes. So you can have, for example, the image here in the bottom left, where the AI recognized the image as containing a banana, probably based on the yellow shovel. But just changing the color of the shovel turns it back into the proper conclusion of it being a dragonfly. So here we can get some idea of why this is happening, but just showing the counterfactual doesn't elucidate why specifically those changes are relevant. And this is precisely what this covering rule is supposed to be doing. So just presenting a counterfactual seems to be insufficient for full explanations, and empirical evaluations of these XAI tools using only counterfactuals seem to support this. So there have been a couple of studies already where you see that simply presenting users with a range of counterfactuals doesn't really help them improve on predicting system outputs. So it seems like they don't get a proper understanding in this way of how the system makes decisions, of why it makes the decisions that it does. And hopefully then, that at least is the idea that the philosophy of science has here, is that adding this covering rule will help there. That, on the other hand, brings up the question, well, maybe we can do with just a rule. There have, after all, been tools doing exactly this. To name one example, from 2017, there's the idea that you can explain the behavior of a classifier F here simply by showing you what subset of images it applies to. So here you will have just a rule. It won't cover any counterfactual cases because it will focus specifically on, in this case, the images for which the classifier returns 1. So in this case, returns Robin images. And it will refrain from mentioning any counterfactuals whatsoever. So this is a suggestion that's out there. I think the question with these kinds of suggestions is, first of all, what exactly is the classifier attending to? So we have this set of Robin images, but we don't know why it picks exactly those images for the label Robin. We don't get some kind of independent conceptualization of the model behavior. But more importantly, there's the general finding in psychology, also mentioned in this literature review by Miller, that explanations tend to be contrastive, so that there's always some specific contrast you're looking for. So why is it Robin rather than another bird, or rather than an inanimate object, or why is it yellow rather than blue? These kinds of contrastive focuses in our explanations, and they will be missing if you have a rule which doesn't cover any counterfactual cases. So independently from this philosophical account, there is the general finding that people prefer these contrastive explanations and will in fact offer contrastive explanations almost all of the time, and then adding the counterfactual component fits in very well with that human tendency to focus explanations on a specific feature. Okay, so to sum up a bit on this part, on sort of trying to define explanation in a general sense, from the philosophy of science, we have this account originally by Woodward that you need two components for a minimally adequate explanation. First of all, a generalization which covers the actual case, and then furthermore a counterfactual case which is also covered by this generalization, so that you need both in order to have an explanation. The question is, however, are these also going to be good explanations? So that's why I have this second part on explanatory depth, because there are very easy cases of what would be explanations on this account, which we definitely don't want to push in the XAI context. So if you have a black box algorithm, then you could very readily present this generalization, which is just exactly the function approximated by the black box. And it would be a covering rule, counting the current instance you want to explain. The function approximated by the black box will return the actual output when given the actual input, and it will contain lots and lots of counterfactual cases. But clearly just having this probably very complex approximated function isn't going to elucidate the algorithm to anyone. So why is this explanation not a good one, or is there some kind of feature that we can look for that will point us to what good explanations would look like? So like it's here on the slide, how can we distinguish this explanation and other bad explanations from explanations that are actually good and that we do want to present to users? And I will be going here into two specific factors that have been picked up on in the philosophical literature, the abstractness of variables, and the generality of the explanation, with the idea being that already very often in the XAI literature, you see that people will say if an explanation is broader in some way or more general, then it's better. Philosophers have been saying the same kind of thing in their discussions on explanation, and there's some further subdivisions to be made here on what type of generality exactly might be relevant for determining if an explanation is a good one. Okay, that being said, I will start off with abstractness here, and again, just an example to get an idea of what distinction people are after here and what the idea is with abstractness. So if you have two competing explanations where on the one hand you might explain why a pigeon pecked at a stimulus by saying that it was scarlet colored, or on the other hand you explain why this pigeon pecked by saying, well, it's because it was a red stimulus, then typically we prefer the one with the more abstract variable. So the fact that you say it was a red stimulus seems to explain more rather than pinpointing a specific shade of red, provided that this pigeon will pick at anything that's red and not just specifically at anything that's scarlet. So this kind of abstractness of the variables, if it matches with the actual behavior of the pigeon or the AI system, seems to help us. We tend to like these more abstract explanations compared to very, very specific ones. And the reason for this, there are probably quite a few for cognitive load and so on. But the reason from this philosophical perspective is that having these more abstract variables allows you to answer more why questions. So the idea is that an explanation answers a question, why does the bird or the AI system act in this particular situation the way it did? An abstraction is one way to be able to answer more of those questions by covering, for example, all shades of red in all the situations in which this bird will peck, as opposed to only the cases where there's a scarlet stimulus. So abstractness here leads to an increase in generality, which is helpful to us in explanatory situations. A little bit on how to define this abstractness then. So there are different accounts here. I think one of the easier ones to follow is the idea that a variable is more abstract than another when its actual value is implied by the less abstract value. So to show how this would work, you can have the case where if an object is scarlet, then it's also red automatically. Simply by knowing which shade of red something is, you know that it's red. Similarly, if something is a fridge, then it's a kitchen appliance. So this is a way of getting a sense of how these levels of abstractness are building up, though there's definitely more to be said here, which, well, I'm happy to talk about. And then the same thing you will have for AI systems. So the input variables of a model are probably going to be much less abstract than, for example, the concept-based explanations that Jay is working on. So simply copying the exact behavior of the model, this idea of presenting the approximated function of the black box as an explanation is going to score very poorly on abstractness. At least most of the time. So in the case of images, this will be very clearly a bad idea. On the other hand, going all in on abstractness isn't going to be the absolute answer either. You can make these explanations too abstract. So one limiting case here is where you might explain why this pigeon was pecking at something by saying that it was either presented with a red stimulus or provided with food or tickled on its chin or and so on. You might have this really long disjunction, giving you a very abstract, very widely covering explanation, but not one that we will be pleased to hear about. This tends to be an explanation that we find very uninformative. So then again, you have the question, well, why is this a bad explanation? And the suggestion here that I will be following is that it's not specific enough. Where to make this a little more precise, the issue is that you can change the values of some of the variables in the explanation without having any effect on the outcome. So if we stick to the pigeon example, to keep things a little more concrete, as long as there is this red stimulus, the bird will peck at it. It doesn't matter. So giving this very broad generalization with lots of disjuncts means that there will be variables in there, like whether there's food or if you tickle the bird, which will be completely irrelevant for changing the outcome. So more abstract explanations are typically better here, but the limiting case is that you shouldn't make them so abstract that you add in irrelevant information by, for example, in this case, adding lots and lots of disjuncts, which do make it a more general explanation, but take away from how specific the explanation is for users. Okay, finally then, we have this idea of explanations being better because they're more general. That's in the end what the explanatory depth of this abstractness is coming from too. So the question is, what type of generality exactly matters here? And like I already said very briefly, the idea is that by answering more of these why questions, so by explaining more instances of an algorithm's behavior, you have a better explanation. And here there are at least two relevant ways of cashing this out in terms of being able to answer more why questions. You can both look at how widely it applies, so the breadth of a generalization, and you can look at how accurate it is. So if we stick to the breadth of the generalization first, then the idea goes that the more inputs the explanation manages to cover, the better. I didn't say this very explicitly in the beginning, but the account of explanation here allows for some inaccuracy in the explanation. So it could very well be that it covers some inputs but predicts the wrong output. And at least according to Woodward and these philosophers, the general explanation might still be a good one, provided it covers enough of the inputs in its range accurately. So you could expand how many of these inputs it covers or is supposed to cover. And note also here that an additional factor to consider is that it's not necessarily the case that an explanation might apply to only a single black box algorithm. And I think that's where this notion of breadth of a generalization can actually help us to get out of the issue of why isn't the function approximated by the black box a good explanation. Because this approximated function only applies to that very specific model, whereas more wide-ranging explanations, which might point to features like models acquiring bias or adversarial cases, might apply to much more than just a single model. And I think these are the kinds of explanations which informally you will see researchers give for a model behavior. They will explain that the model led to this particular behavior in these cases because it acquired bias. There was some correlation between financial data and income inequality, or a correlation between the training data and the sex bias in hiring at Amazon, for example. It's these kinds of very broad-ranging explanations where we point to general features across models, which we find the most helpful. So for these explanations, the at least theoretical suggestion would be that you try to look at how it applies to more than just the single model as well. That being said, simply making an explanation range as widely as possible won't work either, of course, so we have to counterbalance this with the idea that accuracy matters too. So the number of correct outputs that the rule will give you, or the general accuracy of these predicted outputs. So yes, there will be different ways of measuring this exactly. A very simple one would be to just look at whether or not the predicted output is the same or how much it deviates from the actual outputs. So to wrap things up a little bit here on explanatory depth, I've mentioned here how abstractness and breadth and accuracy all factor in to how good or how deep an explanation is. Of course, there's going to be much more that is going to be relevant for whether or not an explanation is good. And I think here factors like cognitive salience or the precision that you have in the contrast class are going to be relevant, as well as more human-computer interaction factors to deal with our specific psychology. But based on the at least philosophical account here, abstractness and breadth seem like relevant, not automatically available in the literature criteria to mention. So to conclude, I've talked a bit here about how we might define explanation in XAI, and I've suggested that we could follow this account from the philosophy of science by Woodward of having a general rule covering the actual case, as well as one, or of course in practice much more, counterfactual cases. And that not all those explanations will be good ones, but that explanations, at least with variables at an appropriate level of abstraction, with decent breadth and good accuracy, are promising from this philosophically theoretical standpoint. And that finally, this also helps to focus on contrastive explanations, which is something we know to be important, but can still be missing from current XAI tools. Okay, thanks for listening, and I guess we can open the floor to questions then, Arkady.
Yes, thank you, Stefan. Exciting talk. Do we have any questions? Please feel free to raise your hand or type it in the chat or just speak up.
I have something.
Yeah, go ahead, Joel.
Sure. So yeah, really interesting talk and perspective on how abstractness and generality can aid in this exploration of explanations. Well, I think I have more of a comment and I wonder what you think about it. Do you think, so to me, all of this sounds really great. And it sounds like we could indeed use abstractness and generality to try and paint out explanations in a helpful manner. But I think the crux of it all eventually ends up on the user needs, right? So on this very last concluding slide as well, you say, in order to identify good explanations, all of these would sort of depend on identifying the appropriate level of abstraction, as well as a reasonable breadth and accuracy, right? And all of these metrics are user dependent, right? So what is a appropriate level of abstraction is something that is heavily reliant on the purpose that you're putting the explanation to, right? So what use is it serving? So I wonder how using abstractness and generalization in the context of chalking out user needs could play a role in serving explainable AI. So I think these two notions are quite nice, especially so if you can tie them directly with user needs.
Yeah, no, I think that's a good point. One thing which might be of help here is this idea of having the contrast class. So by saying that the explanation is answering a question, why is the output this rather than something else, and then the contrast you're looking for might help you specify what level of abstraction you're interested in. So I think if you're looking at a contrast class with a low level of abstraction, so why is it red rather than blue, you might have to focus on a more specific explanation as opposed to a wider ranging question. Yeah, I should be able to come up with good examples here, but I think hopefully the idea is at least somewhat clear that this, by picking which contrasting examples you're trying to explain, so how the current output differs from whatever output the user might expect, that you might be able to determine to some extent at least what level of abstractness and what kind of explanation you are supposed to be offering. There's a further question of how much this depends on individual psychology. If you look at the sort of philosophical literature on this, then they tend to take a very objectivist stance with the idea that there is going to be some kind of level of abstraction that is the most appropriate for virtually everyone. And there is going to be a lot of agreement on which explanations we think are good ones and which explanations we think are bad ones. So this is probably taking it a little too simplistic, because they just assume, well, you have the relevant background knowledge and so on. So there's going to be difficulties there with implementing, and I think you're very right to point that out. But yeah, I think some of it might be mitigated with these contrast classes. Not that that's going to be an easy solution, but there might be something there.
Indeed. So I guess you could, involve the end user in the loop by asking them to provide a desirable level of, a contrastive example or contrastive explanation they need, right?
Yes.
All right. Interesting. All right. Thanks a lot. Very nice talk, by the way.
Thanks, Ujwal. Next, we have a question from Witka, but unfortunately, she cannot ask it herself. I'll read it for you, Stefan. So how do you consider explanations in AI systems that don't directly make decisions? For instance, perception-based applications of computer vision, smart cameras, or speech recognition, the Hi Google in voice assistants. So I think it's basically about the scope of explanation, whether you explain the decisions of AI system or basically just mapping between input and output.
Yeah, so I think this will work quite generally just in terms of mapping input to output. So the context where this idea is coming from is that you have physical systems where you want to explain why one physical event happens based on previous physical events. So, for example, you want to explain why an apple fell from the tree using Newton's laws of gravitation. And I think we can do a similar thing here with different AI systems. So, of course, if they make decisions, that might be the most logical thing for users to ask these why questions about. But I think for these smart cameras or for speech recognition, you might just as well ask, why did the system recognize this phoneme as this rather than as this other phoneme? Or why did the camera recognize this part of the image as a fridge rather than as a table? And then you would have the same question about the correlation between the inputs and the outputs, so across counterfactual cases. So my hope would be that this applies quite generally. If there are challenges there, I'd be interested to know. But yeah, I hope it's quite a general framework at least.
Good, thank you. So I hope that answered the question. If not, please follow up in the chat. And then next in line we have Gia.
Thank you. Thanks, Stefan. It's really nice to see the full story, and it makes me a little bit more confident about the thing that I'm doing. It seems that because it maps all the things that you have talked about, maps very well to the project that I'm working on, right? Using concepts to try to explain what exactly a computer vision model has learned. So my question is. I can already imagine, right, to set up a computational pipeline that can be used to really leverage all those ideas that you have, right? Okay, to what levels of depth we needed to get the concept right for the explanation, and how do we collect all those counterfactual examples, right, to verify that the model has really learned something. But what I was wondering is. Would this like more computational pipeline, right, really contribute to the theory? Would that be helpful at all?
Well, I think there's a reason we're already working together, right, Jay?
Yeah.
So yes, no, I think that's I think you're exactly right there, that this kind of concept-based explanations sound like a very promising way of working out this theory. You're also working on correlations between input and output, and these will automatically cover counterfactual cases. So I haven't given a lot of detailed discussion here about other existing XAI tools, but there are definitely tools out there that already give you, to some extent, a rule that will cover counterfactual cases. So Lime will do something like this, even though it won't be very general explanations. So I think the theory is, in my case, explicitly aimed at making it useful for generating these tools. So the idea here is to try to offer what type of information might be relevant and what factors to consider. And it's very nice that this maps on so naturally to what you were already doing. But that should be the end goal here of doing the philosophy, that we get some more detailed specifications of what the XAI tools should be delivering.
Thanks. That's good to know.
Great, thanks for the question, Gia. And then we have a question from Evgeny.
Yes, thanks. Hi, Stefan. Thanks very much for a really interesting talk, a really interesting look at the topic. So I wanted to ask you, what are your thoughts on the following, that maybe, given how important that is, and given this account, let's say that we want to follow this kind of account of what is a good explanation. So before considering building an AI tool in a given social context, shall we, maybe we should first determine what is a good explanation in that social context. And only once we have determined that, then decide what are the means to provide such an explanation. So, and then approaching that from a socio-technical point of view, thinking what kind of social infrastructure, organizational process, policy, jointly with any kind of technical artifacts that can be part of that infrastructure could actually provide that kind of good explanation. But then we start from what is a good explanation, and then we go to what kind of tools. I'm curious, what are your thoughts about that, if you have any?
Yeah, no, I think that's a good approach. So, and in general, I would be skeptical of trying to dive straight into this and saying this is the final answer on what good explanations are. So I think it would be relevant also to first just do human-computer interaction studies on whether explanations of this type are actually going to be more helpful than single counterfactuals. I mean, this hasn't been studied yet, and I think it would be very important to do this and to also see if indeed this philosophers' intuitions that abstractness and breadth and so on are going to be relevant factors for good explanations, if they actually bear out. It wouldn't be the first time where philosophers have just been exchanging intuitions to the point where you start confirming your own theories. So I think that kind of study on if these are good explanations would be good. And your suggestion to start generally in a context with, okay, we want to give explanations. What is it exactly that we're aiming for? Would be a really good basis before starting to develop tools which you aren't going to be sure will actually help for the problem you're trying to solve. So yeah, I think that's an interesting approach to start with the question, what are good explanations actually in whatever context you're working with, and moving on from there. And hopefully this framework will help a bit to do that.
Because right now, it often the case is that we have some kind of tool in some context, and then we want to reverse engineer and see, well, okay, how do we try to better the tool to provide a good explanation? Whereas
people read the tool correctly, or that they interpret Shapley values in the way you want them to. Yeah.
Because what really your presentation, I think you really nicely gave an overview of a rich body of work that exists out there into the topic of explanation. And that makes me think, well, given also how crucial this is, right, when it comes to real life consequences, that if we kind of reverse this around, right, and say, no, but hey, explanation is a critical requirement to have in a context, regardless of whether we're going to use AI or not. So let's first try to settle to some good extent what kind of explanation, and maybe that inspires a better social process around it, and actually maybe that inspires us to new innovation in terms of the AI tools themselves, if we kind of flip this around. Thanks very much.
Yeah.
Thank you for your point, Evgeny. Then I will read up a question from Luke, who is also not in a good talking environment. So his question is it reasonable to expect that a very smart human will be able to understand the most simple explanation that can be provided? Do you get the question, Stefan? Because I'm not sure I do.
No, but I think so if I'll interpret it a little bit, so maybe the simplest explanation on why the entire model is behaving the way it does might be very complicated because it's still a very non-linear model, and so the simplest explanation for the full model behavior might be quite difficult still. And I think that's a good point. So one of the suggestions there might be is that we generally might not, or well, I think this is actually maybe something up for debate, but we might not need a full explanation of the entire model for any particular why question that we have. So it could very well be the case that we can manage to answer our explanations without these full global explanations of the entire model if they turn out to be too difficult. But that we can offer more focused explanations on the different parts. So I think that the easy cases here to focus on is say adversarial examples or biased outputs, where we have a simple explanation for specifically that part of the model behavior. And so if we can somehow manage to carve up our model behavior into these different parts, then maybe that will be enough to understand it. I think that's an open question. So it's a good point to raise on if we will ever be able to fully understand these. But it's something to work to strive for anyway.
I hope, Luke, you're happy with the answer. I don't have any other questions in line. Perhaps someone wants to just ask impromptu question. Yeah, Evgeny, go ahead.
Well, if nobody else would like to. So yeah, Stefan, so maybe you touched upon this in one of the previous responses, but so I was curious, given that many current AI tools operate based on correlations, so our attempt to explain their behavior causally, so at least at first glance, that seems to me to run into a kind of guesswork zone that like we then try to interpret it, and we think as humans a lot of our daily interaction with the world is based on a causal interpretation. So we try to interpret it, but these interpretations there might be actually off, right, from what this correlation-based model does. So can you talk a bit about how do you see this?
Yeah, sure. So I think there's an important difference here in terms of which causes you're interested in. So Juan, for example, in our group, who's also working on explanations, he's interested in how you might give scientific explanations of phenomena in medicine using AI tools. So he wants to get to these causal relations that are out there in the world between a medicine making you better or not, using the correlations that AI will spot. And that's, I think, related to your question a bit. So that's one goal you might have, and that's going to be tricky to infer causal relations out there in the world based on the correlations that the AI models are working with. A separate question here, and that's more the sense of causal relation that I was interested in, is that there is going to be a cause, namely you put some information into the model, and there's going to be an effect. The model outputs something, and this relation, basically just the model behavior in any particular computer, it will be a causal relation with just computations being carried out by the CPU or the GPU. That causal relation is the one I was interested in explaining. So that's a different one from the causal relations out there in the world, but still a very relevant one, because we have the input to the model as a cause and then the model output as the effect, and it's based on these correlations in data, which is what we want to get out of it. But yeah, the causal correlation talk can get very confusing if you don't keep this very strictly separate.
I see. Thanks very much. Thanks for clarifying that. Yeah, because I was thinking about it in terms of the other one. Yeah. No, but that's a really interesting perspective. I mean, because that itself, then I could see how that can, even if you cannot then causally explain the underlying thing that the tool addresses, it can spark meaningful deliberations among stakeholders.
Yeah.
Thanks.
Thanks again, Evgeny. So Stefan, I have a very general question going, I guess, beyond the topic that you explored, but maybe not. So it has to do with one of the points that Evgeny touched upon, the fact that AI systems are actually parts of more encompassing human AI systems, like complex socio-technical perspective, complex systems perspective, right? Mm-hmm. And then what I think is that most, at least, yeah, I'm only vaguely familiar with the explainable AI literature, but it does seem to me that the focus there is pretty much on the AI part of the system. And my question is broadly, how do we go from the explanations on the on this level, on the AI agent level, to explanations on the level of the system as a whole? And then a good example could be, for instance, this infamous case of Uber test vehicle crashing in Arizona and well, hitting a pedestrian on the road, and the pedestrian died. And then there could be multiple explanations for why that happened, starting from that the emergency braking system that was built in the vehicle was disabled so that it doesn't clash with the AV components of the system. Then going on to computer vision, saying that, yeah, basically the investigation showed that the vision system of the car falsely identified the pedestrian as a bicyclist or as an object, and then it switched over a couple of times, so that could count as an explanation for why that happened. But I think from the meaningful human control perspective, we are more interested in what kind of human decisions have led to this specific outcome, so that, yeah, it's very easy to say, yeah, AI is, bad AI is to blame, but we are not really interested in who is to blame, but what humans need to do next so that this doesn't happen again. And I think this is a completely new, completely different way of approaching things, as opposed to what people in XAI are doing, who are trying to say, yeah, how does this neuron and neural network affect the outcome of the system? So what are your thoughts on this?
Yeah, I think that's an interesting question. So to some extent, the examples you were giving might be captured with these different contrast classes. So why did the car hit the pedestrian rather than brake beforehand, and then you would have the emergency system? Or why did a car hit it rather than identify it as a pedestrian and stop, and then you would have the identification system to which you can point to. So I think partly this is just the fact that there are several facilitating causes, and the difficulty with any of these explanations is to find all the relevant ones. And then I think you're very right to point out that the people in the car are going to be part of this sufficient causes for causing the collision. Or necessary causes, maybe even.
Yeah, but also there are humans. I mean, when I say complex human AI system, it doesn't mean that just the driver, the pedestrian,
no, it's for the
car, but also the designers and legislators, the Arizona state authorities, which basically allowed that to happen eventually. So yeah, it's
yeah. So I think I'm not sure if the kind of talk I was giving here is going to address that issue in any way. I mean, theoretically, you could probably fit in all these different explanations that you're after into it. But just saying, well, look for some kind of covering rule with counterfactuals isn't going to tell you which explanations to look for, or more specifically, which questions to ask. But I think it's an interesting idea here to draw the types of things that you want to explain more broadly than the current XAI literature might be looking at. So, and that's going to be an interesting challenge to look at. Yeah.
Okay, great. I think we are running out of time. So if there are no burning questions, wait a minute. No, nothing. So thank you so much, Stefan. That was a very interesting talk, and I really enjoyed the discussion. Thank you, everyone, for contributing to that. Okay, then I think this is our last Agora meeting for the summer, and I think we will meet all of you starting from September again. Thank you. Bye-bye.